Assalamualaikum warahmatullahi wabarakatuh. We are students from PHY210 from UiTM Tapah Perak. So we're gonna present our topic, which is thermal physics. So our video contains four main subtopic, which is the first one is introduction to thermal physics, the second one is temperature and thermal equilibrium, the third one is thermometer and temperature scales, and the last one is calorimetry. Our group consists of 4 members, which are Najwa, Binti, Ruslan, Nurul, Izzah, Binti, Othman, which is me, Puteri, Balqis, Rabbiatul, Addawiyah, Binti, Mohamed, Riduwan, and Rabiatul, Adawiyah, Binti, Alauddin. Without getting any further, let's begin with our first subtopic, which is introduction to thermal physics. So what is thermal physics? Thermal physics can be defined as the study of heat. Heat energy or thermal energy is the energy of a substance or system in the terms of the motion or vibration of its molecule. The faster the molecules in the substance move, the more heat energy they have. For example, we have a glass of water here, so if you want to know how much thermal energy there was in a glass of water, you would have to total up the energy of all the molecules inside it. Also, for your information, a large glass of cold water has more heat energy than a small glass of cold water, but they feel just as cold. Because of this, we introduce a related term, which is temperature. Next subtopic, which is temperature. What is temperature? Temperature is defined as the average kinetic energy of the molecules in a substance. A measure of how hot or cold something is the degree of hotness of an object. A large and small glass of water might have the same temperature, even though the large glass of water contains more overall heat energy. Heat can also transfer, so thermal physics talks about this as well. And SI unit for temperature are Kelvin, Celsius, and Fahrenheit. It can be measured by using thermometers. Many properties change with temperature. Most materials expand when heated. The freezing point of water is 0 degrees Celsius or 32 Fahrenheit, and the boiling point of water is 100 degrees Celsius or 212 Fahrenheit. So the thermometers are instruments designed to measure temperature. Next, let's take a look at the conversion of units. So the conversion between both scales can be given as, if we want to find the temperature in degrees Celsius, we must use this equation, which is 5/9 times with temperature in Fahrenheit minus with 32. Or if you want to find the temperature in Fahrenheit, we must use this equation, which is 9/5 times with temperature in degrees Celsius, then plus with 32. And if you want to find the temperature in Kelvin unit, we must plus the temperature in degrees Celsius with 273.15. And this is how the thermometers of Celsius and Fahrenheit looks like.
Hello and Assalamualaikum. My name is Puteri Balqis Rabiatul Adawiyah Binti Riduwan. My ID number is 2020877452, and I will present about heat and thermal equilibrium. Definition of heat: energy transfer from one object to another object because of a difference in temperature. Heat is transferred from hotter object to a colder object. Heat can be measured in unit of calories, kilocalories, and joule. It can be measured by using calorimeter or joule meter. Conversion of unit: 1 kilocalorie equal to 1000 calories. 1 calorie equal to 4.186 joule. 1 kilojoule equal to 1000 joule. 1 kilocalorie equal to 4.186 kilojoule. Calorie is the amount of heat necessary to raise the temperature of 1 gram of water by 1 Celsius degree, and kilocalorie is the heat needed to raise the temperature of 1 kilojoule of water by 1 Celsius degree. What is the differences between temperature and heat? A temperature is a measure of average kinetic energy of individual molecules, or a measure of how hot or cold something is, or is the degree of hotness of an object. Meanwhile, heat is energy transfer from one object to another object because of difference in temperature. Heat is transferred from hotter to colder object. Temperature and heat both are scalar quantity, which is quantity that only have magnitude. But temperature is a base, which is that cannot be defined by other physical quantities. Meanwhile, heat can be defined through multiplication or division, which is derived quantities. Temperature using Kelvin as the SI unit, meanwhile heat using calorie or joule. Thermal equilibrium. Two bodies or objects are said to be in equilibrium if they are, first, at the same temperature, second, has the same kinetic energy, and third, no net exchange in thermal energy between two bodies. The step of the thermal equilibrium. When two objects with different temperature put in thermal contact, the heat will transfer from hot to cold object. Eventually, the both objects will reach the same temperature. So, the heat between two objects hot and cold will be somewhere in between.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rabiatul Adawiyah Binti Alauddin. My matrix number is 2020824148. Today I want to discuss about thermometer and temperature scales. Firstly is thermometer. What is thermometer? Thermometer is a medical instrument that allows you to take your core temperature, which is the temperature of your heart, brain and other organ. The accuracy of ear thermometer is high because they can detect the infrared heat emitted by the eardrum and provide precise result. They must be used with probe covers on. But if they become dirty, an alcohol cotton wet cloth can be used to clean them. Infrared thermometers, on the other hand, are a wonderful alternative for a quick and contactless reading. Number 2. What are the type of thermometers and its use? Firstly is mercury or liquid in glass thermometer. Mercury thermometer were previously the sole way to take a temperature. Mercury thermometer may shatter easily due to safety issues, such as the fact that they are constructed of glass, enabling poisonous mercury to escape. The second type of thermometer is oral thermometer. A digital or mercury thermometer can be used to take an oral temperature. Oral temperature average 37 degrees Celsius. Any oral temperature ranging from 36.1 degrees Celsius to 37.2 degrees Celsius is considered normal. Some people run naturally cold while others run a little warmer. It's a good idea to know what your normal temperature is so you can tell if you are running a fever or when you are sick. The third type of thermometer is forehead or also known as temporal thermometer. Infrared sensors are used in forehead thermometers to detect the temperature of the superficial temporal artery, a branch of the carotid artery. Non-contact infrared thermometers are the name given to certain of these devices. Forehead thermometers that do not require physical touch have grown in popularity for usage in places like airports, shops, and stadiums. The temperature of forehead is around 1 degree Fahrenheit or 0.6 degrees Celsius lower than the temperature in the mouth. The last type of thermometer that I want to discuss today is app-based thermometer. The majority of free phone applications designed to capture temperature readings are intended to record the temperature of surroundings rather than individuals. Phone applications that let users to take their temperatures rely on digital thermometers that communicate with the app through Bluetooth. The next topic is temperature scales. Firstly is Fahrenheit scale. The Fahrenheit scale of the temperature is the common form of the temperature measurement used in United States and some parts of the Caribbean. The Fahrenheit temperature scale includes negative temperatures, those below 0 degree Fahrenheit. The absolute zero temperature is negative 459.67 degree Fahrenheit. Number 2 is Celsius scale. The Celsius scale is used to measure temperatures throughout the majority of the world. In the early 18th century, two variants of the Celsius scale were developed. The Celsius scale is sometimes known as the centigrade scale since it is based on a 100-degree difference between the freezing and boiling temperature of the water. Third is Kelvin scale. In the 19th century, the Kelvin scale was developed from the Celsius scale. Kelvin temperature is extensively utilized in scientific equations and computation because to its direct relationship to absolute zero. By adding 273.15 to a Celsius temperature, you may convert it to Kelvin. Water freezes at 273 degrees Celsius and boils at 373.15 degrees Celsius. Kelvin is the standard or unit of measurement for the ideal gas.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ruslan. My ID student is 202081196. So now let's move to the topic 5.4, which is calorimetry. Calorimetry is the process of measuring the amount of heat that being released or absorbed during a chemical reaction. Calorimeter is a device that we use to measure the heat transfer and to determine the heat capacity of material. It is an isolated system which both energy and matter are conserved. Temperature is the measure of the heat transfer. So basically there are three types of system, which is open system, closed system, and also isolated system. Open system is the condition which both matter and energy can be exchanged with surrounding. Closed system is the situation where energy can be exchanged while matter cannot be exchanged with the surrounding. And the third one is isolated system, which both neither energy nor matter cannot be exchanged with surrounding. Here are the examples of the system. For open system, we have a cup of coffee without the lid. For closed system, we have the kettle with the lid. And for isolated system, we have the thermos. First law of thermodynamics said that energy can be converted to another, but it cannot be created or destroyed. The fundamental equation of calorimetry state that heat loss by abrasion is equal to the heat gain by the water and calorimeter. Heat gain is equal to negative heat loss, thus Q calorimeter plus Q water is equal to negative Q of reaction. When different parts in calorimeter have different temperature, the heat will flow from hotter area to the cooler area until they reach the same temperature called as equilibrium. To solve any calorimetric calculation, we use formula Q equal to mc delta T. Let's move to the calorimetric problem. A 200 gram of coffee at 95 degrees Celsius is poured into a 150 gram cup initially at 35 degrees Celsius. So what will be the common final temperature of the coffee and the cup when equilibrium is reached? Assume there is no heat flows to the surrounding. It is also given the capacity of coffee and cup. So how to solve this problem? As I mentioned earlier, we use formula Q gain is equal to negative Q loss. In this equation, the heat gain is cup where the heat loss is the coffee. So just insert the formula and substitute the values obtained from the questions and let final temperature as the subject because we want to find the final temperature, and we will get the answer. Final temperature is equal to 85.84 degrees Celsius. So actually it is very easy if we truly understand the topic. Okay, so that's all. Here are some references that I use. Thank you for watching.